Right. Good morning, everyone. Thanks for showing up. This must be the least popular talk, so don't yawn too much, even if you think it's boring. As Jimmy said, I'm Bert. I work on Node and mostly on LibUV, actually. There's a StrongLoop logo for some reason, I don't know. On the internet, I go by the nickname Piscasaurus, which might be convenient if you want to hit me up on IRC or something. I'm going to talk about, the talk was supposed to be called Introducing Node.js. Actually, we're not going to introduce Node.js because we took a slightly different take on the things. But I will be talking about what Node.js was about and what we're going to do with it instead. But first of all, there's like code here. There will be many slides with code. This is the only one you actually need to look at if you're not feeling for it. And I will explain what it does. And let me first explain what it does. There's a function here. It's called curl. It's a node, of course. And it takes the URL and a callback. And what it does is basically downloads a web page over HTTP. And there's a very lightweight caching mechanism in there. And this code actually works. And so to demonstrate this, let's switch to my terminal, which is now on the wrong desktop. Yep. So it's not very interesting. This is node wrong.js. Yeah, like this is google.com. You can see a lot of JavaScript. You don't want to read that. But it actually works. You might think there's no bugs in this code, but actually there's 3 bugs. And what I want you to tell me is, what are the bugs? Where can this go wrong? And actually, the StrongLoopies can participate, except Miroslav, because he knows the answers. And so, please, I'll give you 1 or 2 minutes. And there's a URL there that redirects you to a gist if you want to look at it on your own laptop. So, by the way, if anyone sees a bug, please raise your hand and just tell me what you think it is. For my colleagues, if you don't find at least one of them, you're not getting a raise this year.
It's a good motivator. You're not listening on error and the return value of HTTP. Wouldn't it have an error?
The return value of this?
Yeah.
And I should be listening on error. Anyone who agrees? Is this true? Yeah, Sam is right. He gets the first. Yeah. Absolutely. That's my first problem. And so if I put in a wrong URL here, then that doesn't actually exist. It will crash. Okay, I'm giving you 1 more minute. Okay, I will tell you, look at this, what's going on with error, and look at this line. I mean, I'm giving it away basically.
That's your
Look,
console.logging the null?
Yeah, that's true. Yeah.
What is, yeah.
And that's not. Okay, I'll just give it away. Look. If you, this function is supposed to be asynchronous, but what happens here, if it's in cache, I'm making the callback synchronously, and you might know this is really supposed to be bad. You're not supposed to do this. So what people should have to do normally is put process.nextTick around that or something, and then look at what goes wrong when not the I forgot to do error handling here. Actually, I actually forgot this. Miroslav pointed it out yesterday. But what if something goes wrong with the response object? So, the normal flow, if it's early on, we go here, right? The error is emitted, and we just call the callback with the error, and it's fine. But who says that after end, no error can happen? In fact, I will tell you, I don't know. For streams, for TCP streams, it definitely can happen. I think for HTTP connections, if you're not using connection pooling, this can also happen. Like the problem, of course, is that like most people can write Node code, but nobody actually gets this right. And so what we have to think about, I work on Node Core, what we have to think about is, can we make this easier? Can we make this better? And so this is like a slightly trolley slide. Node.js 1.0 is not even released yet, but we have to start thinking about Node.js 2.0. And that was something we were trying to do an experiment in Node.js where we actually solved this problem. But right now it seems that we are actually going to try to get it in core earlier. And so exactly. So another thing, this summer, it's summer, right? People have not so much on their hands. Their company is kind of slow. So people start sort of reflecting on the tools they use. And what happened is posts like this came up on our mailing list, like future of asynchronous programming in Node. And usually that means people will propose that we add promises to it or whatever. And future of Node streams, we need to talk because now Node has streams 3, I think, in the next version. So, but still people are not happy with it. And the question is, and usually what we do is tell them, no, like this is going to happen the way we think it's going to happen because we have to focus on Node 1.0. But these people are not crazy. They have a point. Like as I showed you, like it's hard to do it right with streams, and especially to not get your error handling wrong to make robust apps. And so the most interesting part, in my opinion, was, let me see if the next slide will actually come. Yeah. This was a post by Miguel de Casa. You might know him from porting Mono to Linux and stuff, or writing Mono, which is .NET on Linux. And he says, callbacks are our generation's go-to statement. And that particularly resonated with me because I actually think this is true. And it made me remember something that I did when I was 8. I wrote stuff in Visual Basic in GW Basic. And one of the problems it had no functions and no subroutines. I think later versions of GW Basic actually had go sub, but it only had go to. And so what people would have to do when they wanted to when they wanted to abstract certain behavior is, like roll their own functions. And this is what I used to do. Save the return, like it had lines, of course, line numbers, very, very modern. You would save like the return line, which is this one, right? And then go to somewhere. And like here you do your function body, and then you jump back to whatever line you saved. This worked, sort of. Except that like you had to renum every now and then. I don't know if you ever programmed GW Basic. And of course, if you renummed, it was smart enough to know that if after the goto would come like a real number, but if there was a variable, it would not know that. Now you had to change this because this line had another number now. So that was always extremely painful. Anyway.
Did GW Basic have labels?
No. Like this is like, I think Quick Basic or Q Basic or something got that first. No, this is like super old. It's like from the 70s. Like my computer was old even when I was young, so you can imagine. Like it was really old. So anyway, of course, this talk is not about GW Basic, but what I realized is that people actually in Node, they do sort of the same. Like, does anyone recognize this pattern? Like you have to wait for 2 events and then go to some sort of next step. And you can use async parallel or something to get that done. But this is basically an implementation of a semaphore. Like this is a very old-fashioned construct. Now you suddenly have to do it yourself because we are in this very modern programming environment. Let's make it even worse. Can anybody tell what this does? Like it probably is hard to read, but maybe it's a recognizable pattern. It's somewhere in the internals of Node where you have transform streams, and you know how transform streams work. Instead of you giving Node a callback, Node gives you a callback, and you're supposed to call it. But people call it synchronously, secretly, and so we have to detect when people do that. And so what happens is we set sync to true, and then we call your callback somewhere here, and then we look, and then we set sync to false. And if the user made the callback synchronously, we know that sync would still be true. And if they made it asynchronously, we know he would have made it asynchronously. Like this pattern, it will show up in many library codes. And well, it's insane. People should not have to do that, in my opinion. So to summarize, welcome. Come sit down. To summarize, like what are typical problems that people run into that like breaks their app? They call a callback that's supposed to run once, twice, or they never call it, so your app hangs. You're not handling errors effectively, as I showed in the first example. Like there's obscure ways how it might fail, and then your application crashes. This also another sort of problem with Node, because everything runs in the same process. If you have an intern to write the contact form on your otherwise very great website, but the contact form has a bug, then every time someone who fills it out and something goes wrong, your process crashes, or your nice socket.io clients suddenly are disconnected. Ad hoc ironing out of flow control kinks. So that's what I mean with like implementing your own semaphores, implementing your own, see like next tick or not next tick smartness. These are all things that people have to do now because callbacks are just go-to statements in a way. So the question and we have to ask is, can we do better than that? So I think we can. So ideally what we want to do is add a construct to Node, like that makes it easier to manage callbacks. And now everybody can say, oh, that's promises. It might be promises, but the thing, of course, with promises is it's very focused on one particular problem, which is the Christmas tree, and like people want to flatten that. I think we need to do more, and you want to express intent and not an abstraction and not flow control. And what I mean by that is like modern programming languages have while and for, and of course everybody understands that's just a glorified go-to statement, right? Or a conditional and a go-to statement. The thing is, if you say while, you mean like do something for, until a condition is true or false, and for is like looping through something. And that means that if you read the code, you can actually see what it does, versus if you like see the example semaphore that I just showed you, it's like, what does it do? You have to decipher first what actually happens, and then you can understand what the intent of the programmer was. And my eventual, and then the beamer disconnected.
And when you said modern programming languages, you mean languages that's been around for like 25 years, right?
Mm-hmm.
It's really like the ones that have for and while loops, right? There's nothing modern really about them. They're old languages. I mean, C had for loops forever, right? So I guess the point is that we're not even, with Node, we're not even where languages have been, normal languages have been 25 years ago, right? You're bringing basic, but I don't know which year, I guess you started programming. You look pretty young.
Probably 1990 or something, yeah.
1990, yeah, but I mean, we had for loops forever, I think.
That's true. So the funny thing is, of course, that like these programming languages did not really do asynchronous, right? They did not like have secret ways to put things on the back burner and continue doing whatever you were doing. And so and we're still figuring that out. So let's do the discussion like after the talk and go on. I mean, I still like Node a lot, by the way. I mean, like bitch about it because that's my job to like dislike it. But in reality, I still like it a lot. But I think what we really want to strive for is to give you tools to build robust applications to like that just don't crash. Like right now, Node has, for example, domains. They're sort of like a baby step in the right direction, but we have to go much further than that. And because I want to add stuff to core, it has to be unopinionated. You know how the Node community gets up in arms when you try to add stuff to core? Like you have to be really careful about that. So let's find, and of course, it shouldn't break too much. There's, I don't know, what is the current count? 30,000 NPM modules? You don't want to throw that all away and do it all over. Just a bit silly and a waste of time. Let's not do that. So let's come up with the minimal structure that we can improve the situation. Have an asynchronous try-catch block. So do stuff here, asynchronous stuff can be included here, and then eventually go somewhere else. Like this could be sort of your callback. By the way, this is not what the API looks like, of course. This would be meaning adding to JavaScript, and that's what we don't do as Node Core developers. But anyway, asynchronous stuff here, and when that's all over, we get there. Very simple. And it doesn't matter if like you get a callback that fails in there, or you just throw an error, it's all routed to the next part. So if we actually make this into a way that we could add it to core, for example, we could tack it onto the domain module that we have in there already. So pass a callback to some function. It captures whatever you do in there, and then give it another call, and give that domain.task constructor another callback, and it will use it as an error first callback, as you are used to eventually. And if you do this, actually, this seems very simple, and that's actually what I want to. It has to be very obvious and sort of, duh, why did we never thought of that before? And the nice thing about it is you can actually nest these things. So you can also, and that, for example, doesn't work with current domains. If you add a task within a task, then first this will all run, then we will go here, and then when that's all done, and anything else you do in the outer task, for example, this timeout should also finish, and then eventually we'll go there. And if you want to sort of set a result value, oh, and that's the other thing, we pass, every time we pass a function to your task, and that's the function that you can call if you want to sort of have a result out of your task. And that result, of course, for example, you can call it here, complete null, something +1, and that will end up in, oh, I have to look very closely. Yeah, so this one will end up here, right? Like the inner task, you call the complete function of the outer task, so then it ends up there. Very simple.
Can you explain what set callback does?
Yeah, so of course, there's many, like, yeah, of course. As I said, like, so this function gets called first, and it captures everything asynchronous that started in there. But then what you want to know is really, did something go wrong in there, or did it succeed? And you have to pass, and Node will call that function much later because it has to wait for all this asynchronous stuff to finish. So that's why somehow you need to pass in another function. And I think I made a mistake here. So look at this one. You pass it another function, and that's the one that runs eventually. And I will explain why it looks like this in a minute.
So set callback sets the callback.
Yeah, for the task. Yeah.
That eventually gets called if it fails.
Mm-hmm.
Or even
Also if it succeeds. Yeah. Yeah. So like look at. Right. So we have a sort of a try block. And we have like a catch and a finally a sort of combine it to one single callback. Okay, let's carry on.
But with that,
Oh.
that might cause like a context switch, right?
Yep.
Okay.
So, for example, the first example I showed you, and that's the funny thing. That's why set callbacks look like this, actually. Suppose you have this function that might have errors, and you don't know what there are. It doesn't matter. You can now wrap them in a task. So this is what we added, and like that's the line we added, and we increased the indentation a little bit. But otherwise, the function is the same. Notice that I removed the error handler. We no longer need to do that because task will just capture any errors that happen. And the funny thing is, because we have this set callback method, what we can do is the callback that gets passed by the user to this curl function just goes straight right there, and so it is a very easy way to wrap whatever existing code exists, and it makes it work. Sam?
That doesn't look to me like it solves the initial problem we described, wherein an error can occur after end, because it'll complete in end, but then an error could occur later.
No. That's the okay. So here's the thing, and maybe I didn't explain that clear enough. You can call the complete function, but it basically sets the result of your task. But it will not immediately go to this callback. It will wait for everything, all the asynchronous stuff that's in the block to go away. And so by the time we actually call like this callback or whatever you pass to set callback, you know that the stream has gone, like the HTTP response and request, they are gone because we waited before everything would go away, right?
How is it going to know that how's it going to know the event that signals the, like, honest to God, I will never have another event from this event emitter on this result ever again?
You mean, yeah, it sounds too good to be true, but you know, there's nothing wrong with this dog, it's just ugly. But yeah, event emitters become a problem. And the reason is actually, so if we go back, like this is a very similar example. If you create an event emitter within a task, we can just wait for the event emitter to go away. Because like if you do stuff like this, the event emitter will be tied, for example, to a socket, to a database connection, or maybe to a file if you use fs.create file, or create read stream, whatever. And so Node can detect when sort of the underlying resource goes away. But the problem, of course, is that people use event emitters also to share things between multiple contexts, sort of. Yeah, context is maybe another good word for it, but between multiple things they're doing. So, for example, you might create a database connection, and then within your task, send one query and wait for a row, and then you might create another task and do the same. But the database connection is shared between multiple tasks. So the question is, how can we like deal with this? So this is the current plan. In addition to event emitter, I'll add something that's that has a little bit more logic to it, called a resource.
Wait,
Oh, sorry.
do you have like an example in which event emitter is a problem?
Yes. Well, I mean, is it a problem? Well, for example, in this case, so the question is, for example, what if like this MySQL object, which I assume here is an event emitter, what if it errors, for example, or what if it just decides that the connection should be closed? The problem is that in the current situation, you would attach an error event to the MySQL connection, and it would live here, right? Like somewhere where just after you created the thing. But within the task, now the state gets sort of crazy because suddenly this event might never come, right? Like the row event might never come because if this database connection is in an error state, then yeah, it will probably not emit any more events. So the question is, how is this task ever going to complete in that case? And so yeah, that's to give you an example. I can give you other examples as well. If you look, for example, in Node core, if you call set timeout, actually what happens is timers are pooled. So if you call set timeout with a 1 second timeout many times, actually Node will create one timer. Suppose this timer could go wrong somehow, then can we pass this error to the set timeout somehow? Like how do we deal with this problem? And so you have to think of, and that's what I will explain now. You have to think of sort of an event emitter as like a sort of small process, and if you attach to it, then you are vulnerable to its failure and to it going away. And then if you remove all the listeners, then that situation is no longer the case. So that's what I want to do. All tasks that have a listener on a resource, that's basically what it comes down to. So if I say database.onRow, I'm suddenly vulnerable to what might go wrong with the database. And then when the row, and then when you remove the listener, or I could have said database.once, and then it automatically goes away after one row, then this vulnerability is over. And then when the task is completed also, the task is completed. It doesn't care anymore about the event emitter, so errors should no longer affect it. But the default behavior, of course, is that if an error happens within a task, we do something reasonable. We pass it to the callback. But you can handle errors within a task. It's very simple, similar to what you do nowadays with event emitters. I'll show that in a minute. But what we also have to say is that a resource, like any event emitter, has a well-defined endpoint. So I think that's one of the problems that we had in the first like wrong code example. Nobody really realizes if end is really the last event, or I think in the practice it's usually close, but not always. I'm thinking of examples where close is not there. Oh, and sometimes it's finished, for example, for writable stream. this is very hard for people. Nobody can remember this. I look at the node source code usually when I really want to know. It's not very practical. So a resource has to have a well-defined end, and the end can be, well, okay, well, you ask for it to go away, or it implicitly, like, a process just exits, then it implicitly goes away, or it ends in an error state, and after that you will have no more events, and it should be predictable. And the other thing is, since a task becomes vulnerable to errors that happen in shared event emitters. So this is the database example again. Now the task, if it really wants to ignore this error, within the task you have to add an error handler to it. And then like the context that created a task also needs this. So in this case you would actually have two error handlers. If you would omit this one, then the task would go to the callback with the error that happened to the database connection. If you omit this one, the process would crash, just like it does today. And that's obviously to ensure that current code doesn't break, or we are not silently discarding errors. Okay, so let's focus on some more stuff that we can do with this. Think of a timeline of a node program. It's not really well readable still. I ramped up the saturation, but like a node program usually starts at some point. So that's here. This is the first tick, and suppose that it calls set timeout and accept is basically what happens under the hood when you call server.listen, for example. And node can only run one thing at a time, but at any particular moment in time, multiple things can be sort of happening in the background. So here there would be a set timeout happening. The accept callback has passed, but is still reading from a socket, and here we are actually executing the callback from another accept, another incoming connection. And so this is the direction of time basically. And in this callback we spin off a read, and that happens in the background for a while and then comes to a conclusion in a callback. Like that, this looks sort of, you could actually print this out for any node program. It would be very big. You could do it. The only problem is if an error happens and we print you a stack trace, node really, it obviously doesn't know if an error happens here, what would have happened in the future, and it has forgotten about all its past. So the only thing node in theory knows is I'm in this callback. Maybe it knows that it just spun off a write, or it hasn't done that yet because it's in the function where the error happened, and it knows that a set timeout is happening at that point. It doesn't really help you when you are debugging your code. So that's why usually when an asynchronous error happens, your stack trace is worthless. The funny thing is though, that we can actually, if you create tasks, you create sort of a structure around multiple callbacks that happen or multiple asynchronous stuff that happens at the same time. Because you're capturing everything in one block, we could say, well, this all belongs to task, task serve user, you serve a web page, I don't know, or serve a chat server. And so whenever an error happens, we could sort of look that way and see, okay, that's the task it's related to.
Right. But there's an overhead to that, right?
Mm-hmm.
You have to keep track of all the past contexts.
Mm-hmm. Yep. There's an overhead to that, yeah. We can. It's not. I don't think it will be very big in the end. If you nest tasks, we can actually we can see that there's an outer task which might be serving a web page, and this could be rendering a template, right? And so you have the error happened within serving a web page, within rendering a template which was related to serving that web page, whatever. And if we can actually name those, and that's easy because you can name your functions, we can actually give nice names to the task that we're waiting for. And then a stack trace could look like this. And the error in this case is not very interesting. But what you can see, we will tell you, okay, the actual stack was this. This is sort of the useless stuff you get from Node. And then, okay, this was part of another task, and you started it there. In this case, because you can't look at the code, it doesn't really help you much. Another thing is obviously like the thing we do with StrongOps, or not obviously, but the thing we do with StrongOps is we actually want to it would be nice to be able to say, well, this logical block of code, not necessarily this function, but this logical function of code takes that much time, spread out over a number of callbacks. And because we just decided to name our tasks and sort of nest them, we can actually give attach useful labels to groups of callbacks, basically. So I think this would be very nice. Obviously, it doesn't work yet. It sort of worked a week ago. So there's still room for discussion. If anybody has questions, if you have a suggestion, if you say this is shit, come talk to me. If that's what it makes you feel. You can follow me on Twitter. You can also follow StrongLoop on Twitter. They will definitely retweet me. I don't know. Where's the marketing guy here? Yes, he will definitely retweet me. And so if there's anything that you can play with, you will be the first to know. Thank you very much. That's it.